German, because there's coming up a microphone. We didn't want to do a speech again, weil Sie uns gesagt haben gerade, lassen Sie uns doch mal ehrlich miteinander reden und nicht wieder eine Rede abreden. Wir haben Ihnen sehr viel zu verdanken in den letzten 2 Jahren, wo wir fast zufällig zueinander gekommen sind auf einer großen DroneMasters-Veranstaltung in Hannover. Sie haben in den vergangenen 2 Jahren sehr viel gesehen zu automatisierter Mobilität im Luftraum, über all das hinaus, was wir gemacht haben. Was hat Sie besonders beeindruckt?
Was man hier auch sehen kann, also diese kleinen Flieger, wo man alleine oder zu zweit drin sitzt und dann doch senkrecht hochkommt oder fast senkrecht hochkommt, gibt ja unterschiedliche, und fliegen kann. Ich glaube, wenn wir vom autonomen Fahren reden, dann reden wir im Grunde vom autonomen Fliegen. Weil wenn man autonom fährt und dann hat man eben keine Begrenzung mehr, also muss man nichts mehr machen und dann kann man auch gleich eine Etage höher gehen. Deswegen glaube ich, diese Entwicklung wird parallel weitergehen und ich finde es große Klasse, um das Lob mal zurückzugeben, dass Sie in den letzten Jahren so viel dafür gemacht haben, dass sich diese Technologie in Deutschland entwickeln kann. Denn wenn wir sie nicht gehabt hätten, wären wir nicht da, wo wir heute sind in Deutschland. Das muss man auch mal sagen.
Vielen
so, jetzt
Dank.
mal Beifall bitte. All denen, die Deutsch verstehen.
Dankeschön. Die große Sprache, also wir freuen uns sehr, wir sind das 2. Mal hier auf einer IAA New Mobility. Wir waren letztes Jahr bei der LKW Commercial IAA mit einer DroneMasters Logistics, wo Sie auch schon dabei waren. Was wäre aus Ihrer Sicht sozusagen die Erwartung an die Industrie? Wir erleben die Autoindustrie als sehr offen und zugewandt, weil sie auch Automobilität neu denken. Die Erwartung, was kann die Industrie noch tun und die Wirtschaft, um tatsächlich die vielen Dinge, die überall in Deutschland keimen und in Europa, wir haben tolle Beispiele aus Europa hier, um das stärker voranzutreiben?
Die Aufgabe ist, glaube ich, ein Modell zu entwickeln, was bezahlbar ist. Zwar teuer, aber bezahlbar. Und was so gut funktioniert, dass man es in unterschiedlicher Art und Weise verwenden kann. Man kann da vorne beispielsweise das Teil sehen, was fliegt, aber wo es dann auch zusammengeklappt wird und oben auf dem Auto dann einfach nur noch Licht wie so eine Skibox und damit als ganz normales Auto eben auch bewegt wird. Also ich glaube, das wird einen echten Mobilitätsschwung nochmal bringen, weil es dann eben auch im normalen Straßenverkehr zu benutzen ist.
Das ist das, was man dann wahrscheinlich hier gerne irgendwie als Brückentechnologie begreift, in anderer Form.
Sie wahrscheinlich.
Sozusagen der nächste Schritt der Evolution, der hängt vorne bei Daimler mit Volocopter, was
das
ja auch ein tolles Start-up ist, vor allem, weil die auch sehr alleine angefangen haben und auch mit Crowdfunding es geschafft haben, ingenieursgetrieben das nach oben zu bringen. Und das ist, glaube ich, eine Lücke in Deutschland, die wirklich noch da ist, dass es schwer ist, jungen, mutigen Unternehmen die notwendige Finanzierung zu geben. Sie haben viel
Das ist aber bei dem Thema, glaube ich, nicht das Problem, weil ich glaube, dass wir inzwischen in dieser Legislaturperiode viel gemacht haben, damit die an Geld kommen können. Ich glaube, das größere Problem bei uns in Deutschland ist die Politik und die Regulierung. Das ist wenigstens meine Wahrnehmung. Es fängt an mit dem E-Skateboard, was hier nicht betrieben werden kann und dann kann man solche Geräte nun erst recht nicht betreiben. Das ist irgendwie alles schwierig. Da müssen wir auch ganz klar in der nächsten Legislaturperiode in der Politik besser werden. Wir haben das jetzt in dieser Legislaturperiode versucht mit dieser Drohnenverordnung, die ja auch noch ein bisschen notleidend ist. Ohne Zweifel. Also das muss einfach besser werden, weil uns sonst, es hat keinen Sinn, dass wir in Deutschland die Technologie entwickeln können, dass wir sie dann aber nicht wirklich in den Verkehr bringen können, sondern dass das dann immer über andere Länder funktionieren muss, weil wir einfach die Regularien nicht hinkriegen. Das ist schlecht. Da müssen wir, das muss man ganz selbstkritisch zur Politik sagen, müssen wir besser werden.
Das heißt, damit haben Sie mir im Grunde genommen die letzte Frage schon vorweggenommen, aber im Grunde genommen geht es darum, dass Politik die Rahmenbedingungen beschleunigen muss, dass wir schneller werden können, die tollen Technologien auch in die Luft zu bekommen, nicht nur auf die Straße, in die Luft. In dem Sinne, wir bekommen jetzt hier schon angezeigt, noch 59 Sekunden. Ich will das jetzt Ihnen sozusagen auch hier nochmal eröffnen. Ganz herzlichen Dank. Es war großartige Unterstützung. Wir hoffen, dass wir Sie bald wiedersehen, in welcher Form auch immer. und Ihnen noch einen tollen Nachmittag hier auf der IAA. Es gibt vieles Spektakuläres zu entdecken. Danke, dass Sie heute hier waren. Nochmal einen großen Applaus.
Na, viel Applaus für Sie. Ich finde es klasse, dass Sie das jetzt auch hier wieder organisieren.
Dankeschön. Tschüss. Bis zum nächsten Mal. So, and now we switch back to English. Thank you very much, Brigitte Zypries, Federal Minister of Economic Affairs and Energy. My name is Wernecke. I'm the founder and CEO of DroneMasters and also a host of Panel 1 today of this very first DroneMasters conference. It is not the very first DroneMasters conference at all. It is the first one on mobility. It's the first one on air taxis, manned drones, flying cars in Europe. And I have to admit we are second globally because there was another tiny corporate named Uber, which did the first conference on flying cars and air taxis in April. So when we decided to do that, we didn't know it, but we are definitely first in Europe. We're second on the planet, and I'm very proud of this because competing with Uber is really cool from our perspective. But that is not what it's all about. It is more about the innovation and the acceleration of this upcoming evolution. Do I have a pointer just to have a little question, or do I make little signs when I want to go to the next slide? Why we are here today, apparently, can somebody go forward with? Do I say next? Yeah, that's cool. This is one of the major urban challenges we are currently facing, and I don't have to repeat it all because this whole IAA, the new mobility world, is all about solutions and new ways of finding and arranging how we can solve this upcoming traffic congestions all over the world. Interestingly, we are all focused two-dimensional. Next. This is a very well-known picture. It's not so charming, but it was done by the city of Münster in the beginning of the 2000s. And what it shows you on the left side is that they made a poster showing how much space is required to transport 60 people by car, by bus, and by bicycle. And thank you. And one of the major points about this is that you see how much space is needed, and nobody really thought of going up in the air. And what you see on the left side, or on the right side from here on this, is a meme. And this meme was done by somebody, John Orchid. He posted it on Twitter 2 or 3 years ago. He is in his main job, he is in the Department of Transportation in the city of New York. And so he's facing all these traffic challenges every day. And so what he says, what we get a solution with cars, it's still, with cars, Uber, autonomous cars, we still need 60 cars to transport 60 people. So the question is, why is nobody looking up? So that is not true because a lot of guys looked up in the air because they were inspired by movies, Fifth Element, Back to the Future. They thought about flying cars. And some people started to develop flying cars. We're going to see 2 lines how these things currently actually work and how these machines are out there. But it was still something very unique, very so engineering fantasy. It was something for the nerds of engineering. And that was due to a very complex part, and that is highly complex currently to fly a helicopter. What you see here is a Bell helicopter from inside, and it's a really difficult task to go into vertical takeoff and landing and to fly back and forth. But we see also digitization all around the globe. And basically what you have currently is whatever you can buy in a warehouse, in a store for 50 to 80 euros. It's the same technology, it's electric, it's digitized, it's something you can scale really, really far up, and it's the same technology which makes it possible to transport goods, cameras, and people. And the true disruptive power behind it from our perspective is that you can disconnect mobility from infrastructure because you don't need roads, you don't need waterways, You don't need railroads. You can make it happen that this is what we all saw in the movies can really become a reality. And people just start to understand what it means, that you can transport people and goods from A to B without having a transportation infrastructure. The real challenge about this is that we all perceive that as a linear process, and that is evolutionary reasoned, because we are not scared until we have it right in front of us. And the challenge with exponential changes is that they come exponential. It does happen overnight. We see that in technology, we see it in energy, we see it in the automotive area all over the world, and we just have no way to deal with it. And that is what we call the law of disruption, that technological progress is really, really, really fast, and the business models, the social acceptance, and the regulations are pretty much slower. And what you see behind it, it's all about speed. And the function of DroneMasters as a company is to accelerate this evolution. We want to speed up companies, startups. We want to make it happen that automated aerial mobility and the use of drones across all areas is really happening. That is why we started DroneMasters meetups all around the world. That is why we set up a platform and a company as an incubator, as a company builder to make things happen which somewhere deliver and enabled by themselves. And we connect experts all around the world, because we have all these silos where you have the automotive industry, you have the aviation industry, you have the IT industry, and everybody is playing around with drones. But they didn't talk to each other. And what we started to do is just to bring these people together and in big venues like this here and in little meetups. And then we have more than 2,500 experts coming together. We are a strong part of the drone ecosystems, and we utilize sports as an innovation driver because it has a lot to do with fun. And you can make also sports a vehicle to make competition feelable, that you can see, you can compete, you have numbers. Who is faster, who is higher, who can lift more, who can do what and what. And we started in 2015 with a major outdoor race in Berlin. We had close to 100,000 visitors in Hanover last year with the first indoor race, and we always mix it with industry. So last year we had a huge DroneMasters summit. We had a DroneMasters convention for the third time in Berlin. We invented a drone marathon for industrial drones, which means we have drones there up to 30,000, 50,000 euros just flying around to compete who's the fastest on a certain distance. We had the DroneMasters logistics at the first New Mobility World last year, so we're very grateful to be here again. So the point is, we connect, we facilitate, we accelerate. That is why we are here. Why we are here at the DroneMasters Mobility. And I'm very happy to welcome our first speakers for the first panel. Alex Zosel from Volocopter. Please, a big applause. Markus Hess. Hi.
Hi, Frank.
Hi. Hi. How are you? Markus Hess from Palvi. And these two guys, you can see their products on this fair. That is really awesome. John Brown and Carplane. Very warm welcome, and give him a hand. Thanks. Welcome. And Robert Vergnes, Neva Aerospace. Welcome. So we have France, Netherlands, and Germany, and I'm very proud that we have these pioneers here. So this is going to take your seat. How it's going to work is that everybody's presenting their technology. It's not about competing, it's just to give you an overview. And we had Mathias Thomsen from Airbus with a cool Airbus project, and we got a call this morning that he has to apologize because he had to cancel his flight for an emergency reason. We have an idea that this is really true, and we really miss him. I guess somebody from Airbus is here. When you have questions, we can address them later. But now the floor is to Volocopter, and I'm very excited to have Alex here. So the floor is yours.
Okay.
And this here is the thing, I think.
Hello.
Yeah. You have a movie.
Like a pointer. Do you know how it works?
So you can start the video. So my presentation is. So we are the pioneers, I think, of this kind of air mobility in the future, because this was 2011. We made the first all-electric vertical takeoff and landing worldwide in the human history. So we are a little bit pioneers in this area. And we decided 2 months after the first flight that we want to have in the future mobility in inner cities. So we really decided in the early times of the company that aircraft, what we wanted to create, has to be as safe as a commercial airliner. So this is a little bit scary, or to see this yoga ball flying device and going to a two-seater like that. But the decision was it must really safe. And this is for what we are working hard the last 6 years. And we have a lot of backwind from the authorities. We had 2012, there was a safety report of the FAA about helicopter accidents. And at the end of the report, there was pictures of the yoga ball, our first proof of concept, and they saw that out of the concept, it must be much more safer than a traditional helicopter. So we are happy that we have really backwind from authorities all around the world with that project. And we are also be proud that in the last 2 years, it's a little bit mainstream. Air taxis are coming. Big companies like Airbus want to do it, and other big companies. And so we are working hard to get the next levels. Because for us, it was clear that the first step is a piloted aircraft. Because to work together with authorities, a piloted aircraft, they know how to do this. We have worked hard for this license we get. That was last year. We get for the two-seater a license to fly all around Germany, so we can fly normal as every other sports aircraft in Germany. So, but the next step is our big future dream is to bring air mobility to everybody. And how you can bring it to everybody, it's that this person don't have to have a license or anything. So it must be a full autonomous aircraft, and you can order it only, for example, with your smartphone. And for that, you have to put a lot of other new technologies in an aircraft like this. And so we are really proud that also we are, every 3 months, we are new proud, because every 3 months we have a new milestone in our history. It's amazing that the city of Dubai gave us a call, and they asked, okay, we want to do the regulation for full autonomous air taxis. And they asked us if can we be a technical partner to work with them on that. And so we decided, okay, we speed up more our technical aims into the autonomous systems than to make a piloted aircraft and then have the stages like in the automobile industry. You have 5 levels of autonomous. You start with the piloted thing, then the pilot, the car driver don't need the steering wheel, but it's a steering wheel, and when something happens, see like this, and there are a lot of steps to the full autonomous driving. And if you do this with flying things, you have for every step your own law to create a law for every step. And that was, for the Dubai guys, it was a too long distance from the time, so they decided we make now a project that we have laws for full autonomous. So we'll have a trail between 3 and 5 years there, and the aim is to make the specification for the laws to have full autonomous air taxis. And this is really a good chance for us, then, because there will be a lot of new technologies we have to integrate. It's about sense and avoid. It's like the small drones. It's a big area, sense and avoid, that the aircraft know itself to avoid some things. But there's a big field of air traffic management system. So it's about connected aircrafts, connected with authorities, connected with other aircrafts like rescue helicopters or parcel package drones and things. And these are the main things in this project in Dubai. So we're working hard how we can connect all these aircraft, also with the safety regulation people. And so we see that the future of full autonomous taxis, it's nearer than you can believe. This is so the end of my presentation, and you see at the end some pictures how we think it will be in the future.
Thank you. One of the real true pioneers. We have all pioneers around here. So 3 to 5 years.
Yes.
And then we're going to have, so what I understand is that it's not a technical challenge, it's more regulatory? Or would you say it's on the same level?
It's both, because you don't, at the air traffic management system, there's all over the world different kinds of authorities and players are working, how we can do that. And there are, for example, in Italy, I think they gave it now to the Italian authorities that they have to do the air traffic management for the lower airspace. In the other countries, nobody knows how it goes, but there are a lot of working groups working with the authorities in different countries. So this is the main issue, to have a safe system in this lower airspace, and this is about air traffic management system for that. And there are a lot of players, and so I think it comes really first that we have some demonstrators somewhere. So you have an area from A to B. You can fly from an airport to the inner city, and this is a space you are only for that. So that come really fast. But at the end, it's about to use all the airspace over a city for aircraft like ours.
Well, cool. We're going to talk later on. So thank you very much. A big applause again. I think this is amazing. Our next speaker is Markus Hess.
Sorry, one word.
Yeah.
We are just, if you go out 50 meters, the 2X, it's our full autonomous demonstrator, is standing outside in that area in front of the Festhalle. So you can see the real aircraft which flies.
Yeah, another one with a real aircraft is PAL-V. And it's just, I think, 100 meters over there. And I'm very happy to have Markus Hess here. And the floor is yours.
Correct. Thanks, Frank. As Frank already said, our booth is about 100 meters that direction in the Dutch. It's very orange in the Dutch booth. But before that, I would like to actually say many happy landings to all of you fans of new mobility, and welcome to the following presentation. And I'm representing PAL-V, and PAL-V actually stands for Personal Air and Land Vehicle. And we really literally take the meaning, the vehicle off-road. So whatever you heard about off-road vehicles in the past, forget about it. This is really, truly getting vehicles off the road. And to make sure that you don't think I'm just talking aloud here, I show you little videos to prove that we can actually perform what we promise. Revolution through evolution. Why revolution through evolution? Alexander already pointed it out, and they already talked about it. Evolution, because in aviation, everything is about 3 things: safety, safety, and safety again. And therefore, the regulations, what already Frank and Alexander touched, are very, very, very tight. And as you can see, a lot of concepts already came up in the past about flying cars and whatever, but most of them failed. And a lot of them failed because the regulations were actually not in place to test, for example, new technologies. Technology was there, but the authorities to actually test whether the technology worked was not in place. And therefore, companies failed. And therefore, our approach is actually to say, okay, we don't bet because we are good entrepreneurs. We want to take our fate in our own hands. Therefore, we rather base our concept on something that exists, on existing regulations, and then take that platform as soon as the regulations change to the next stage. And this is our approach. And we choose a gyroplane platform for 3 reasons. First of all, it is extremely safe. It is much safer than any helicopter. It is very easy to fly because most of our customers are going to be non-pilot. Therefore, we need a platform that people can easily fly. And third of all, it is much, much more or much less costly than a helicopter. And last but not least, it's easy to convert it into a small car, in our case, into a 3-wheeler. You may say, how can a 3-wheeler be actually stable and safe on the road? That was one of our breakthrough technologies. There was a Dutch company called the Carver, and the Carver actually developed a leaning technology. So because we have a high center of gravity, we need to make sure that on the road it doesn't kick us out of the curve, so we lean into the curve. And I can tell you it becomes a very, very safe vehicle, but not just safe. It is a fascinating, thrilling, spectacular ride in such a car because you're actually flying low, really low level, like 30 centimeters above the road like in a jet. Tell you, this is a super duper experience. And Jeremy Clarkson kind of proved it. You know, he even said from Top Gear, you know, he's never had as much fun in the car as in a Carver. So what is our target group? We definitely, you know, attract people who love to do 2 things. First of all, become more efficient, increase their productivity, and at the same time, they want to have fun. And this is something that we can actually provide with our PAL-V. And maybe some specs on our PAL-V. It is a 2-seater. It has a max speed on the road of about 170 kilometers. It accelerates below 9 seconds. And in the air, it has a cruise speed of about 150 kilometers, max speed 180. And it takes, you know, about 150 to 200 meters to take off and to land about 30 meters. And you've got a useful load of about 246 kilos, meaning 2 average persons with full gasoline and a little trolley with about 20 kilos of baggage. And last but not least, as I mentioned before, we base it on a platform, and the platform is adaptable to future. So if regulations change, and there are actually the possibilities of, for example, making things autonomous up in the air, we will have a platform that's adaptable. Same is true for electric flight. I mean, currently, at least for our customer clientele, the range, because of the energy density of batteries, is not big enough yet. But once there are batteries that have a much better energy density, we will actually provide electrical flight in our PAL-V. But this is going to be years down the road. Thanks a lot, and yeah.
Thank you very much. So the first one was electric. This one is it a gasoline machine?
It's actually 2 certified aircraft engines which run on regular unleaded gasoline 95, which you can get at every gas station.
That's cool. And one, if I would like to buy it, may I ask how much I have to invest?
Yeah, it's right, sure. It's in the area of a Ferrari with a few extras, but as you know, a Ferrari can't fly, and
yeah,
it does.
That's true.
So it's 299,000. That's where it starts, and it goes all the way up to 499,000. So if you want to have your name engraved, you can have that too.
Okay. Well, thank you very much. So we come to Carplane. So John Brown, the floor is yours.
Thank you. Just waiting for the display. There we go. In the future, there are going to be, there we go, there's going to be air-based mobility, otherwise known as flying cars. Now, there's a lot of confusion about this. There are 2 types of flying cars. One is operating within a city from roof to roof. The other one is operating between cities and is not roof to roof. It's not a vertical takeoff and landing, but it's runway-based, like the PAL-V vehicle that we just saw. Now, there we go. Now, the type of vehicle that we have from Carplane uses airstrips and roads. And this isn't working. There we go. 2 days ago, I came here from Munich. And the options you have nowadays are train, car, and plane. In future, you'll have the option of a carplane. Now let's look at how you would get here from the north of Munich, the Allianz Arena. Get to the Munich airport first. You have to call a taxi. There we go. And it takes you 15 minutes to get the taxi. It takes you another 20 minutes to get to the airport. And then your flight goes to Frankfurt every 2 hours, so you're waiting on average 60 minutes, unless your flight has been canceled. But you need those 60 minutes to check in, go through security, find your gate, line up to get in the airplane, line up again on the air bridge. Hopefully you'll have space for your luggage, and then you'll be in a cylinder with 100 of other people, unless, of course, the plane is overbooked. You get something nice to eat, which I mean sarcastically. And the actual flight is only about 25 minutes, even though with the checking in and out, you need about 55 minutes, and then you take a taxi into Frankfurt town. Now, with a car, you just drive out the front door, get on the A9 freeway and the A3, and it takes you about 3 hours and 15 minutes, unless, like 2 days ago, you have a total of 31 kilometers of traffic jams. So here's the future. Besides all of the international airports, there's about 600 small airstrips, we call them, spread throughout Germany, spread throughout the whole of Europe. You're only ever an average of 28.8 kilometers from such small airstrips. And here's our vehicle, the Carplane. And you just drive from the front door of where you're going. It's not roof to roof, it's door to door, to one of these 600 little airstrips. It's only 6 minutes away. And you pull up to the runway. And once you get near the runway, there's no tower you need to talk to. There's no flight plan you need to file on these little airstrips. You press a button, oops, do that again, and you turn your car into an airplane. And then when you're ready, you take off. No checking in, no security checks, and you're on your way to Frankfurt. But you don't land at the main airport. You land at a little airstrip called Egelsbach, and from there, you just pull up to the runway and take your taxi into town. Or you don't take a taxi, you drive your carplane into town and pull up at the front door. Now let's compare. A train will take you about 270 minutes. Car and airline are about the same. A carplane beats all of them. And the same goes for costs. The direct costs are quite competitive as well. Now, the technical challenges are quite strong. The most important one is the width if you're using wings rather than rotors. A car needs to be not more than 2 meters 20 wide to fit in a garage or the lane of a road, whereas a plane, think of a glider, the wider, the better. A plane just simply does not fit in the lane of a road. So what we did was we simply automated this process. Just what you see every weekend, people towing their gliders to the airport and putting on the wings. It only takes 15 seconds. We've patented that around the world. The second problem is aerodynamics. A car should not leave the ground at 70 kilometers an hour, but a plane should. And if you get this wrong, really bad things can happen. So we took technology from Formula One racing to do that. It's basically the way we store our wings. The third problem is weight distribution. Cars have the weight spread evenly over 4 wheels, and planes have it at the rear, otherwise they couldn't rotate to take off. If you do that on a car, you're not going to get around the corner. The way we solve that problem with Carplane is just we simply extend the tail and move the center of gravity. The final problem is the most difficult one. Anybody from Volkswagen here? It's the emissions control. Airplanes don't have emissions control. So to solve that problem, we, at this moment, have a special engine which is compliant with the Euro 6 standard. And in future, we're going to be working with Siemens on a hybrid electric version. Going past my time here because I can't get this thing to work. And what we want to do with this electric motor is take off and land without making any noise. The challenges, I'm not really in agreement with Alex on this one point. Anybody can build a model. More than 300 people have gotten something to fly with somebody on board. The real challenge is certification. Nobody's ever gotten a flying car certified before. A lot of people have tried. Last November 14th, we passed our final test with the aviation authorities here in Germany, and we just putting the plane back together again now to fly. A lot of people have tried to do this. Very few have been successful. So please wish us luck. Thank you.
Thank you very much. One question is like, how's the engine working? I mean, how do you get it up? Is there propulsion inside, or did I?
Well, if you look close, you'll see there's a propeller between the hulls.
Okay.
It's what we call a pusher propeller, and it also drives the rear wheels. In the future electric version, we will have 2 propellers between the hulls, 2 electric motors for redundancy reasons, and we'll also have hub motors on the rear wheels.
So when the engine turns off for whatever reason, you can still do it like a glider, and you have no...
Well, the type of redundancy we're going to have with a battery, a generator, and 2 electric engines is actually better than the modern twin-engine jets. Because if one engine fails, you still have the other. If the batteries fail, you still have the generator with a puffer.
Okay.
If the generator fails, you have the battery and have 30 minutes of reserve. So we get a very high degree of safety, which, as Markus was saying, is the most important thing in aviation.
That is true. Thank you very much. We're going to talk later on. Last but not least, Robert, this is all yours, and we're very excited. Oh, here, it's over there.
Okay, right. Thank you.
Neva Aerospace.
Thank you, ladies and gentlemen. This is our vision of what most probably will be the future, and slowly but surely the transportation will change, and the market for transportation will switch to aircraft. Now, as several of us before pointed out, there's some issue with safety. At Neva Aerospace, we believe that the way to make aircraft safe is to use distributed propulsion and to use electric turbofan. So now let's look at why you would like to use distributed propulsion. Why? Because when on airplanes or standard helicopter, usually you have 1 or 2 engines. If one fails, then you're in serious trouble. I'm sure you all know that. That's why when you have distributed propulsion with electric systems, your failure rate will not impair the flight. So if one of your motors would fail, you will still be able to complete your flight and safely land. As well, it would be electrical or hybrid, and then reduce CO2. So this is quite important. The evolution is not going to take place very fast. We've seen before with Alexander the electric Volocopter, which is a great demonstration of distributed propulsion. In order to go further, we need new thrust systems. So we've developed new thrust systems, electric turbofans, which are now on the market since a few months. We've released in June a new turbo drone, the ERL-X4, which you can see on the, I think I have a pointer, but not working. The number 2, which you can see here. And we're now working on Vlinder and some other evolution, which I will introduce here, which is called AirQuad 1 and the Evolution Mark II. This is an application for an ambulance. So let's keep in mind that this is a big machine. It's 8 meters long by 4 meters wide. If you would develop all the swept areas of the turbines, you would end up with a very similar areas as an helicopter, because you need this swept area to fly. The main difference is that we use turbine, so it's much more safe, because if one of them fails, then the others can overthrust and then provide enough thrust to landing. But as you see, there's a long way to go from what we have today with one turbine or several turbines to a system like that. It's probably going to take a few years. But this is something which we think will take 2, 3, 4, 5 years maximum. The technology is relatively simple in essence, but as often, the devil is in the details. We are targeting several markets, and mostly business to business first, and for MAVs, so manned aircraft vehicles, and UAVs, unmanned aircraft vehicles. As Alex and my other colleagues mentioned before, you got several issues with the regulator of can you have non-pilots people into an aircraft? Today, this issue has not been solved. And if you have people in an aircraft, so it's a manned aircraft, then you need to have at least one pilot. That's a regulation. Regulation would have to evolve, obviously. Waiting for that, most probably we believe that only specific applications will happen. We have several ongoing programs. Two of them, one is the Maya program for an X-Wing VTOL, and the other one is the Air Quad 1 program. And as you can see, all these programs require quite a lot of funding. Funding is between 15 million to 100 million, depending on where you want to go for civilian certification of aircraft. So it's going to take time, because when you put something into the air, you have to get certified. And as it has been mentioned before by Markus and John, you have several ways. Either you go through evolution with systems already existing, which are already certified, which you improve, or you get something brand new, and then you have to go all the way through certification, which takes a bit of time. So we believe this will take 3 to 5 years at least. That's all from my side. Thank you very much.
Thank you, Robert. Thank you for coming here. I can take that. You can go back and forth.
Yeah.
When do you think we will see the new one flying?
Today we've done tests up to 50 kilograms. We are planning tests around 150 kilograms in few months. As it was mentioned earlier by Alexander, you need to do all your tests step by step. The laws of physics are such in aerodynamics that each time you change scale, it takes a bit of time. So our time frame is 5 years.
5 years.
Yes.
So apparently in 5 years we're going to see it all flying, so we can sit down now all together for our last little discussion. Question number 1 is answered. When will we see it all in the market? It's probably in 5 years. So I missed one. We have Airbus, not on stage, but we have a video to make it all round. So we have innovative young companies, engineers working on this technology for quite some time. And we also have the aviation industry, which is really testing and pushing all this forward. So could we please see the video?
In less than 20 years from now, more than 2/3 of the world's population will live in cities, and many in megacities with more than 10 million residents. One of the drawbacks will be gigantic congestion. Many cities are already facing that, where time has become an increasingly rare commodity. So Airbus and Italdesign have linked up in a groundbreaking venture to imagine solutions. And the concept they've come up with is called Pop-Up.
Pop-Up is a new mobility concept. It's multimodal. It combines ground with the air. It allows passengers a seamless and faster way getting from A to B using the city sky. It's a partnership between the aerospace and the automotive sector. Two powerful sectors that comes together to develop new technology, new concepts for the future of smart cities.
What they've come up with is a modular concept that can both fly autonomously using electricity and travel on street level or even on other modes of transport such as hyperloops. Using an app, passengers will be able to order the 2-seater capsules from the airport or train station, for example, to their final destination using this kind of transportation system.
I think right now the urban sky is quite underutilized, and that's exactly the proposition. The grid-like layout of road doesn't actually do it for us. We think that by combining air and ground, we will get a much better use of the space that we have in our cities.
While for the time being the project is a concept, something which looks very similar to this could be a reality within 7 to 10 years from now, because Airbus, with its extraordinary we make it fly know-how and Ital design, one of the most innovative players in the auto industry, are highly ambitious. Who knows what other partnerships could emerge?
Well, we think that both companies believe really in finding the best solutions for people in future mega cities or in generally in transport. So Airbus is doing this on their way, in their field, and we are doing it on our ground-bounded transportation, so trains and automobiles. So when we combine these skills into a research partnership, what it is, then we find very dedicated people on both sides. And we wanted to make sure that we take down the boundaries between these different specialities and find the best solution for future megacities. And with this idea, we came up with a concept that combines the best of both worlds.
So yeah, I would have loved to interview Mathias today here, but yeah, he's very sorry. He says hi. So we have the inventors here. Another one who got in a partnership with an automotive corporation with Daimler just a few weeks ago. What is your expectations to working together with such a major corporate?
So Daimler is not the first strategic investor, so we have also Intel on board, so we have American corporate and a German corporate, and so we want to learn a lot of them, also from Intel, also from Daimler, and also we have the possibility to join their knowledge, and this is a good thing for us. But we have our own also a lot of knowledge, so it speeds us up, it helps us, and it's a good thing to have these partners on board.
So it's more, yeah, engineering speed up. It's experience, what they can provide. It's less the topic of money. It's more know-how. Is that right?
Yeah, you can collect thumb money or you can collect intelligent money. And for us, in that stage we are now, it's important to have real good partners, because we want to scale really big up. So we don't want to produce, for example, if you produce 500 helicopters per year, you are just a global leader. So the market is not so big, but we are believing that we want to produce hundreds, thousands of Volocopter in the future. And so we need skills like a car maker. And Intel, for example, they are really good in ecosystem of drones. They have a lot of invest in hundreds of drone companies. And so we have, for a sense and award, for example, everything what is coming out of the Intel world in this area we can implement in a really short time. So it's a good thing to have strategic partners, but also we have also other partners on the other side. So it's a good mixture.
Thanks. Markus, do you also see hundreds of thousands PAL-Vs around the world if the economic numbers are getting up and we are all able to afford a vehicle like that? Or is it more that you say it's more a niche market also in the future, or do you think this is mass transportation?
If I have a good night's sleep and I have nice dreams, I'm dreaming of hundreds of thousands of PAL-Vs, but to keep my feet on the ground, I think before we get to that stage, I will actually be below the ground. Therefore, we personally think that, especially in the beginning, it's rather going to be a niche. Nevertheless, the niche will expand. I mean, in some sense, you can compare mobility with smartphones. I mean, in the beginning, 12 years ago, whenever, it was just a few of those, and suddenly they just boomed like crazy. So therefore, I can actually imagine something that we know from science fiction, but I think that's going to be beyond our life expectancy.
Why did you choose to come here on an automobile fair? It's not an aviation conference, it's an automotive. So that was your decision to,
yeah, I mean,
was your driver?
In some sense, it is implied in being a flying car or a personal air and land vehicle. It's a matter of how you define the vehicle, but let's say 50% of our concept is a car, And therefore, why did we come here? First of all, it is definitely a place where potential customers may come by. Second of all, you do get a lot of media attention. And third of all, it is maybe also a good way of finding partners. So, I mean, Alexander just mentioned it, you know, they've got 2 strategic partners on board, and it never hurts to have good partners.
That's true. What kind of partners would you look for, or will you do it all by yourself, John?
Well, we're very lucky to be financed by a German state government, Niedersachsen, and we have enough of our own financing to get close to market. Of course, when we're talking about manufacturing large numbers, and we're all hoping that scenario is going to happen, then of course we'll need other funding and a strategic partner. But we don't really have any preferences. I think it's such a new area of technology, it's hard to say exactly which direction it's going to go.
And what kind of a partner would you look for? Is it more automotive, more aviation, more IT?
We've negotiated with several large automobile companies. We're actually negotiating with one right now, and also with players in the aviation and in the drone technology sectors. So we'll see where it goes.
Okay. Robert, the last picture of your presentation, it was an emergency vehicle, and from my perspective, emergencies can be a major driver, because what we see in the hurricane areas in the US, but also in China and in other areas of the world, the first necessary vehicles coming in are helicopters, and everybody's looking for autonomous vehicles. Is that the reason why you decide to go in that direction?
Yes, this is correct. Today, helicopters have a very high price for maintenance. The purchase price for helicopters are quite high, the maintenance as well. Usually between a standard fuel helicopter and an electric helicopter or electric rotorcraft, you would have a factor between 1 to 10 sometimes. So for governments and agencies, it's very important to reduce their cost, and they would certainly prefer to have more vehicles available with less expenses, and be able to be more available to the citizen. That's quite important.
So we have 2 more panels coming up. One is on air traffic management, and one is on regulations and safety security issues. Where do you think there's currently the most need to hurry up and to develop faster?
I think that first of all, there's many of us have pointed out the issue with regulation. I think the regulator is also trying to keep safe the population. It's his job, and the EASA is doing that as well. The member states regulators, because when something flies, it can also crash. And so it's understandable that the regulator is very keen on checking, what's going to happen with something flying. And it's to us as manufacturers to go through the regulator's requirements for certification and provide them enough certainty if it's an unmanned air vehicle, that this unmanned air vehicle will always be under control. And this will be a challenge, certainly, yes. Especially when you speak about air traffic control. If you have the pilot on the ground and the vehicle which is quite far from the pilot, then there are several ways to do that, but for the moment, inland, there's no specific regulation on how to deal with heavy UAVs remotely, and how a pilot could connect to a control tower and the air traffic management.
So, but the vehicle itself, your drone, so that is an interesting question. How do we call these things? So there's air taxis, flying cars, manned drones, which is, from the engineering point of perspective, wrong. How do you call it? It's a Neva.
When it's an unmanned vehicle, we call it a UAV, but the same technology used with a person inside as a pilot, it's a manned air vehicle, so MAV, which That's the terminology we use.
But we're still looking for the cool word to have it.
Yeah.
So it's remotely piloted. What do you need for kind of a license? Would you need to use
Well, to
Carplane?
operate our vehicle, you need a private pilot's license and a driver's license. And you also have 2 insurance policies. We have a number plate in the front of the car, in the back, and on the side we have the letters for airplane certification. And you have two insurance policies. It makes sense because it's 2 separate risks that you're taking care of. I'm sure in future there will be combined policies, and there might even be a combined operator's license.
Is it the same with?
Yeah, pretty much the same. We do need a private pilot's license and a driver's license as well.
How big is the market currently of people who have both? Pilot license, driver's license?
Worldwide, 650,000 pilots in the United States, and in the rest of the world, another 450,000. So we're looking at 1.1 million people right now who would have this qualification. But looking at the subject in a few years' time, autonomy is a new deal on the road, but it's really old news in aviation. Back in 1913, Orville Wright won a medal for an autopilot. So we just yawn in aviation when you talk about autonomy. And I think when the legal situation catches up, you're going to see autonomy on the road too.
Okay. Where do you see the need to accelerate the development besides regulations? We have Daniel Rubio from AirMap. They're working as others on urban transport management systems. Is that the area where is the greatest need currently?
I think it's we are creating a new ecosystem. So there are a lot of work in a lot of different areas. It's about the air traffic management system. It's about sensor board technology. It's about powertrains, electric powertrains. It's really also about infrastructure. You told we don't need infrastructure, but we need infrastructure. But it's really cheap infrastructure compared to roads and bridges and like that. So for us, it's a big field, and you have to have skills and developments in all these areas. So it's not you can handle it as a small company. So you have to grow fast and take over all these tasks.
What kind of a partner would you choose if you could choose and say, okay, I take one from this industry or that industry?
We're discussing with automotive partners already, as Alexander mentioned. When you look at electric propulsion, distributed propulsion for aircraft, clearly it's very close to what they do in the automotive industry. The manufacturing process are very close. The wiring, everything is really very close to automotive. Much more closer to automotive than the old aeronautic. Because the old aeronautic, you had one engine. This engine cannot fail. So you had to make the engine 100% reliable. And to do that, it's very specific. When you use electric distributed propulsion, it's slightly different because you can have failure. You accept, you tolerate, you are failure tolerant. And it's what happens. You can have a problem with one of your wheels most of the time. Anyway, the car will still be able to drive at lower speed, but still. So it's tolerant to failure. When you have electric distributed propulsion, it's very close as well. So in terms of philosophy and manufacturing approach and engineering design, it's very close to the automotive industry. So they are usually good partners to talk to and to engage for projects.
Just if anybody has a question, please just raise your hand, because this is a very unique possibility to talk to leaders and pioneers of this emerging ecosystem. It's hard to get them all together because it's spread around the world. Just raise your hand and give us a sign, so feel free to comment and ask. Coming to regulations, we have Thorsten Klimke here. He is in favor from the European Commission. They have a great model of airspace. From your perspective, is there anything you need you think there should be pushed more from the regulatory side? I mean, you are going to Dubai because there's somebody really starting and learning. Do we need more learn spaces within Europe where we can do that? I've heard this from Airbus several times, that they say we would like to test it here, but we aren't able to. Is that experience you are sharing?
I think they changed the law in Germany. Also, we pushed that a little bit, and now we can make tests in Germany with that. So it's not so bad with the regulators than everybody see from outside. So if you have they trust you and they see what you do, you can just reach everything here in Germany. This is really good. So we have really a backwind from the authorities, and this is all about safety. And if you have a distributed system with high redundancies, it can be really safer than the traditional aircrafts you have now. And this is the future distributed, redundant systems. And so we don't have to go to Dubai to make some tests. So there's a space of make a whole ecosystem safe, not an aircraft. So to make an aircraft safe, you can do it here. So it's I think a company who wants to start with something like that, it's good to work hard and good with the local authorities on the project. And they will see it can work a lot with them because they are open for that.
That's our experience too. We found the aviation authorities, both the German and the European authorities, very helpful. They call us without us wanting anything from them and give us new ideas. So the classic view that people have in other parts of the aviation industry, that the aviation authorities would somehow stop progress, I simply haven't experienced it. They're trying to make this mobility happen.
Same in the Netherlands?
Yes, in some sense that's true, but we currently don't have that much of a regulation issue because we are actually certifying according to regulation. Therefore, we don't have that much of a difference there. Because we are staying within the rules that are there, and therefore we don't have that much of an issue.
So before we come to a last round, same in France?
I think all over Europe, there's the European agency, the EASA, which is based in not far from here in Cologne. The local member states regulator, I think they are open to usually to new tests. The question comes when an operator will have a commercial operation, and this might be slightly different because you can always find a way to have an agreement for developing tests and having a testing ground somewhere. And this is especially true when you go to electric propulsion and distributed propulsion. This is very new. There is no accidentology, so we don't know the accidentology. Basically, there's no record over 10 years about distributed propulsion electric systems, so it's very difficult to anticipate what could go wrong, what will go wrong. Of course, you make some assumptions and you work out statistics, but it will take a bit of time for the regulator to work out what will be necessary, because there's a real shift between the fuel going to electricity. Because when you go to electricity, then you really want to use distributed propulsion for many reasons. The first one is safety. And then suddenly you break the safety models that is now in use in the industry, because the safety model was based first on fuel engines, make everything mechanical, not electrical, and it was 1 or 2 engines. Suddenly you come to the regulator, you say, well, it's going to be 100 motors, electric. Say, oh, okay. And then there's no certification right now for that.
Yeah,
so Alexander mentioned that laws has been adapted, but we are working, and I'm sure Alexander is doing the same in Germany, but we're working with regulator in order to understand which certification can be used or adapted for distributed propulsion.
So one last round, one sentence, one question. When we meet again in 1 year, what will you have reached then?
I think from our perspective at Neva, hopefully when we meet in 1 year, we will be able to have demonstrated that the efficiency of electric turbines over propeller, because they are usually much safer, and we would have been able to demonstrate very large UAVs in a few hundred kilograms, and hopefully one of the regulators would have provided some commercial license in Europe.
That's cool.
For an operator.
John?
Right now, flying cars are just a vision. Next year, they're going to be an accepted part of new mobility.
1 year
Markus?
time, hopefully, together with our test pilot, we're going to land out there.
And you?
I don't know. Perhaps we will see a four-seater in 1 year.
Yeah.
That could be. But we are working hard on systems you don't see. But we are, I think we have some hot news next year.
I'm looking forward to it. Big applause. Thank you very much. It was great to have you here, Robert Vergnes. Thank you.
Thank you very much.
And yeah, we see each other in the backstage. Thank you, John. Thank you, Markus. Alex, it was great to have you.